Let's get this party started. So what is this, our second day of doing, third day? Third day?
Third day.
Feels like a third day. Day 3 of the torture. We're still working on chapter 2 support. We're gonna be doing more shit with fractions today. We did this a little bit before. See, there she is. I think she wouldn't miss much. I waited just long enough, then I go, I know she'll be here in like 30 seconds. So today we've seen multiplying fractions before, but you're gonna see this a lot in not just chapter 2, but more in chapter 5. So I want to drill down on this a little bit. Multiplying fractions together. When we do that, tops multiply against tops, tops times tops, bottoms times bottoms. And recall that the little point means multiplication. We don't use x's anymore. Now that we're in college, we have variables that x gets used a lot, so we're going to use dots for multiplication. So let's just give an example. Three over 5 times 12 over 7. This means we put the tops multiply together and the bottoms multiply together. That's what I mean by the tops times tops and bottoms times bottoms. Ideally, you want to factor any number that isn't prime. We spent a whole day on factoring. Elizabeth will tell you where you can find all that. I'm recording this. You'll have videos for everything you missed. But we'll factor this. This is 3 times 4, and 4 is 2 times 2. The idea here is we want the fraction at the end to have the smallest number as possible. It's called simplifying. And so anything that appears on top and bottom, we can cancel out. Nothing simplifies here. So we leave it as is. We just finish the multiplying. 3 times 12 is 36. 5 times 7 is 35. Our next example will be this. 4 over 7 times 7 over 9. We have 4 times 7 on top, 7 times 9 on bottom. Now, in this case, there is a number that appears on both top and bottom. So when we simplify it, we cross it off and we replace it with a 1. Putting that 1 in there is pretty huge, because if you end up crossing everything off on one side, like everything on top, if you haven't put a 1 there, you might think it's 0 because everything's crossed off. But that's not the case. It's really a 1. 4 we know is 2 times 2, and 9 is 3 times 3, so nothing cancels out between those. So we're good with doing 4 times 1, and 1 times 9 is 4 over 9, and that's simplified. That's what when we say simplified. You can skip writing this step. This is for visual. While I'm teaching it, if you're comfortable remembering that anything times 1 is the number that it started with, you don't need to write that step. If we had not simplified this, this would have been 28 on top. 4 times 7 is 28. 7 times 9 is 63. The computer, the answer key will not let you leave it that way. No go. Any questions? This might have been a long while for you, it might have been recently. Hopefully, you've all seen this at some point in your life. Let's kick it up a notch. 20 over 42 times 35 over 16. Is, let's start with numbers we think of. Melinda, what are two numbers multiplied to make 20 that you think of right away? 2 times 10. Anyone want to give me 42? Two numbers that multiply to 42. Oh, this is on the times tables.
6 and 7.
6 and 7. What about 35?
7 and 5.
7 and 5. What about 16?
2 and 8.
2 and 8. All right, some of these can be simplified down more, but before we do, let's clear out what we see that's in common on both top and bottom. The 2s and the 7s, right? So right now we have 10 times 5 and 6 times 8. Six breaks down to 2 times 3. And 8 breaks down to 2 times 2 times 2. And 10 is 2 and 5. Now, what I recommend you do is if you need, you should factor to see what disappears or cancels. But if you notice one side has very few things that factor, if you get down to like, if you did just the 10 first and then 2 and 5, you might recognize nothing on the bottom has a 5 in it. So all you're looking for is to get rid of a single 2. All you're gonna find is one number that cancels out the 2. We could kill the 6 and get rid of those. Leave a 1 there. We'll have 5 times 5 on top. On bottom, we still have 3 times 8. So 25 over 24. You're so damn fast, Elizabeth, you're already enrolled. They're like, if I can do it instantaneously. Any questions? None? All right, let me give you guys one to try. Give you like 2 minutes and then we'll do it together. I'd give you longer, but we want to get some stuff done. Let's do 18 over 25 times 15 over 42. You prefer Elizabeth or Betty?
Better.
Betta. Did I say, is your name not lit? I fucking might have said the wrong damn name.
It's Elizabeth.
Ah, fuck. You're right. Betta. Oh, I'm gonna have fun with your name this semester. Beta is the letter we use in this class. It's a Greek letter, beta. It's the Greek B. Now all I need someone here is to be called Alpha and we're fucking complete. All right, anyone want to help me with this? Who's feeling brave? Be brave. How do you know? Well, I love that self-esteem right there. That's good shit. Anybody else feel that they got it wrong? Everybody feels like they got it wrong. That's good. So. I already picked on you, Melinda. Michaela, what can I do with 18? You don't need to do the whole problem, just help me with part of it. What does 18, what multiplies make 18? 2 times 9. Let's see, is Jose here? Coming with 25.
5.5.
Juan Diego.
5 times 3 for 15.
There we go. I love it. You're already picking your own. You're like, I don't want to do that. We already did 42. That was in the last one. I'm going to do 42. Don't y'all cheat on this. So, anything cross off yet?
5. Oh, yeah.
5s. I see something. Michaela,
I have a question real quick. So is it gonna change your answer if you use, like, do you have to use a certain, like 7 times 6? Can you use something else that would equal 42, or do you have to use specific one?
no, you don't. You just need to break it down until you've canceled out everything you can.
So the answer would still be the same if you use something else?
Yes, in fact, we'll do this problem again in just a second and show that. I notice I got a 2 and a 3 here. Check this out. 2 times 3 is 6. Right? Like if I broke down the 6, I'd have a 2 and a 3. Rather than doing that, I'm just going to be clever about it. I'm going to cancel that shit out. And now I'm down to 9 over 5 times 7. And 9 is 3 times 3. And there's no 3s on bottom. So it looks like we got a done deal, 9 over 35. That's as simple as you go. Now, rather than changing the whole wheel here, I'm going to just change the 3 over 18. I'm going to write as 3 times 6. She asked if we could do different stuff. So if I just do it with one number, is that sufficient to satisfy your curiosity? Or would you like to see the 42 broken down into something different?
I want to go forward to do it.
You want me to do the 42? You've got a couple options for 42. We can use 2 times 21 or 3 times 14.
That's what I used with the 2 times 24.
All right, let's see that then. Here, I see that 5 still cancels out. And I don't see anything else yet, but I still have numbers that are not prime. So I've got a 3 times a 3 times a 6, and a 2 times a 5 times a 21. And 6 is 2 times 3. And 21 is 3 times 7.
So the 21 would be broken down until it can't be broken down anymore?
Yes, you want to break it down until to make sure nothing else cancels. Because otherwise it will not be in simplified form. So here we can cross off a 2. We can cross off a 3. And we're left with 3 times 3 and the 5 and the 7. 9 over 35 again. 2 times 21 was the first thing you thought of. That's fucking madness right there. 7 times 6 is on the goddamn multiplication table. You're like, nope, we're going big. Any questions on multiplication? All right, that's good. Let's do some division. Yes, yes, yes. Division. I'm gonna motivate it with a picture. We have 2 cookies from Crumble Cookies. And instead of breaking them up into fourths, like they like to do with their cookie cutter, we're gonna break them up into thirds. So I have 2 cookies. And I wanna see, break them into 1/3 size pieces. I could do, what I'm doing is 2 divided by 1/3 to see how many slices I have. Which is also looks like this, if we write it as a fraction inside of a fraction. Now, you don't need to know how to do fractions with divisions to find out how many pieces we have, do you? How many pieces of cookie do we have? Per cookie?
Oh.
3 per cookie, so how many total slices do we have? 6, we have 6. So check this out. If I just flip this over and make that 3/1. What do I need to do with this 2 and the 3 to make a 6? Multiply it. So what we do is instead of dividing by a fraction. We multiply by the reciprocal, it's called. And I'm gonna use a different number. The reciprocal of 5/7 of 5/7 is 7/5. So that's reciprocal. I think the easiest way to remember this is just flip it. So instead of dividing, we can multiply by the reciprocal. Multiply, we already know how to multiply by fractions because we just did that. And if we're lazy and didn't simplify, it's actually kind of easy. Just multiply all the numbers on top and multiply all the numbers on bottom. The only thing that slowed us down was like simplifying it. Let's look at an example. Have a good example here. (20/42), we had these numbers a second ago. Let's turn this into division. Divided by 35/16. Now let's do divided by 16/35. Let's change it up. What did I have last time? I had some 20s and 42s. So rather than doing division, what I'm going to do is I'm going to rewrite this. The first one does not flip. Leave the first one alone. Only flip what you're dividing by. The 35 goes up on top. The 16 goes on bottom. And we just factored this one a second ago. This was the first one we did. This was 25/24. So maybe I should give you the. Let's do the divided by 35/16. So what do we do? we start with the first one, I made it 45, look at that. I changed the number just a little bit, we got 20 over 45. And we're gonna multiply it by flipping that over, 16 over 35. Let me guess, Michaela, when you look at 45, you think 3 times 15. You're a fucking crackhead. Everybody else, what do you see when you see 45? What do you think of multiplies together to make 45? 5 times 9. Now, if you want to speed up your work, if you factored one thing and you see that one of the other things has a number in it, use that. 20, I know, is divisible by 5, so rather than doing 2 times 10, I can jump straight to 4 times 5. Choose that option, because then the 5s will cancel. 35 is 7 times 5. 16, there's a lot of ways to do 16. I think we did 2 times 8 earlier, but I see a 4 here already. And I know 16 is divisible by 4. 16 is 4 times 4. So if you choose some of as you're doing the later ones, try to choose the multiplication factors based on what you're trying to get rid of. You can help yourself out a little bit. You might not get everything on the first sweep, but that's okay. You can get a lot. I see a 4 that cancels. We only cancel one of the ones on bottom, not both. Which is pretty, maybe I should have pointed that earlier when we canceled the 2, and there's a bunch of 2s on bottom. You only cancel them out 1 for 1. I see a 5 on bottom and a 5 there. And I don't see anything else that cancels. I want to point out that 7 times 5, 7 and 5 are both prime numbers. So unless I can get a 7 or a 5 out of the 9 and the 4, we're done. 9 is 3 times 3, 4 is 2 times 2. Neither of them have a 7 or a 5 in them. So we're done. 7 times 5 is 35. 9 times 4 is 36.
We missed something. When you factored 16 over 35. And 16 is 14 4, why don't you give the denominator?
Say that again. You're right. Fuck that up. Good catch. We had 4 times 5 and we had 5 times 9. 16 was on top. My 4s were on top. And my 35, my 7 and 5 were on bottom. Excellent catch. I totally made that. That was my bad. Thanks for saying something before we were 3 pages later. Because someone is in here going, other people had been going, what the fuck is he doing? I don't know what's going on. Maybe I don't know math. No, your teacher just does stupid shit from time to time. I'd like to say I was testing you, but I think we all know that would have been a lie. The 5s cancel here. The 4s are all 2 times 2. Right? Every single 4 is 2 times 2. And all the numbers on bottom are odd. Odd numbers are not divisible by 2. So we're done. This is going to be 4 times 4 times 4 over 9 times 7 times 5. Let's see, this is 64 on top. 9 times 7 is 63, times 5 is 315. Someone check that in a calculator. Oh, sorry, Daniel, I didn't see your message earlier. $2.15, okay. And even though this is simplified, it doesn't look like it, right? A great lesson in mathematics is the correct answer doesn't have to be pretty. When you're taught math in school, for the longest time, they use nice numbers that just clean up super nice. And the numbers are custom picked. They're cherry picked to make simple answers. But the real world doesn't have simple answers. Very rarely is anything nice and easy. All right, you guys ready for more? Fractions to decimals. Yeah. Fractions to decimals. Let's go with one everyone better know in here. What is 1.00 divided by 4? I'll help you out. I'll put a $sign there to make you. It's 25 cents, which is 0.25. I didn't need the decimals. I could have just easily, or on the left, I could have said that's just 1/4 as well. The 0.00 isn't doing anything here. So in a calculator, I would be doing 1 divided by 4. When there's decimals, do it in a calculator. Oh, yeah. It's too bad you guys tend to be good students. I can't always get away with that. I have a great habit of threatening bad students with the Chipotle protocol. The Chipotle protocol is for evening classes, and if they get all rowdy, I'm just gonna have the Chipotle for lunch next time before class, and we're just gonna shut that door and see what happens. I like to do that threat. Someone always calls me on it. Someone always regrets calling me on it. It's fun time. So when there's a decimal, use a calculator. We're gonna do a bunch of examples. Well, we're gonna do some examples with it, but if you don't know how to use your calculator to do division, show me your calculator and I'll show you how. There are 2 problem areas for students. When decimals are involved. At least in stats. And since that's what we're taking, that's what we're going to talk about. We're going to look at identifying the place value. And we're going to look at rounding. I guarantee you are going to get more problems wrong in the homework in this class due to rounding than to anything else. The computer is not going to fucking tell you you rounded wrong. They are rat bastards. They'll just say that's not how you do it. Try another answer kind of thing. And you should have had a 5 at the end and you had a 4, and you're going to think, I don't know how to do math. You're going to think it's something else. I strongly encourage you always just check your rounding first. Okay. The reason why I say identifying the place value is huge is sometimes they make it easy. The easy is where they say round to 2 decimal places. That's the easy part. The hard way for students is when they, hard, not hound. Hard way for students is when they say round to the hundredths place. Those two things mean the same thing. They will ask you in both formats.
You mean the same?
They are identically the same. So we're gonna write a long decimal number and we're gonna identify all the place values by name, what the name is, so that you can just memorize them. They follow a nice little handy pattern. Does anyone need this up longer? Okay. I know what's missing. The chatty ones. Ashley and Manny are here. That's okay, I got you guys. You guys can make it complete in here. All right, you guys ready now? All right, so let's look at a fucked up number and talk about the place values. Let's go with, I don't know, 9732, that'll be our first numbers, and then we'll do something like 14973. So we'll talk about the numbers on the left, different than the numbers on the right. I presume everyone's comfortable with the numbers on the left, what their values are, but we're gonna talk about them. The 2 is the ones place. The 3 is the tens place. Seven is hundreds place. The 9 is the thousands place. There's no reason it's gonna get bigger than that for you. The reason why I do those is because the numbers on the right of the decimal follow a very similar pattern. So on the right, I've got 14973. Maybe I better pause because I think I wrote a lot and people are still writing. I do it right there. No fucks are given. I don't care. All right, everyone looks ready. 1, we want to call it the ones place, but it's not. We're gonna call this the 10th place. I literally took the 10 and slapped a THS on it. The 4 is the hundredths place. It's the word hundred with THS slapped on it. Nine is the thousandths place. Again, THS just slapped on it. 7 is in the 10,000s. And 3 is in the 100,000s. Now, I'll let people finish writing before I start pointing out the pattern. I got 10 here, and I got 10 here. I got 100 here, and I got 100 here. I got 1,000 here, and I got 1,000 here. They literally go in order. It's the same sequence as the left. The only difference is on decimal places, as we're moving away from the decimal, first off, A, there's no 1th place. There's no 1th place. And B, we are adding TH. Those are the only difference in the numbering sequences. Most people know what the numbers are going to the left. It's the numbers going to the right that fuck up a lot of people, but they quite literally follow the same pattern, which is kind of neat. The reason why it starts at tenths is this. 0.1 is equivalent to 1/10. Or 1/10. 0.01, the second decimal place, is equivalent to 1/100. Or 1/100. 100. So they're named after what the fraction equivalent would be for the single value. You guys ready to look at rounding? We don't have very many minutes, but we'll get started on it, go through the basics of rounding, get some good shit in today, and I really hope we'd be done with chapter 2 today, but we're not. I underestimated how long it would take to do the support for chapter 2 and chapter 3 have the longest support sections. All right, everyone ready? Rounding. Let's say we have 0.23456. So when they ask you to round to a specific decimal place, we want to look at the number to the right of it. All right, so now what we do from there is if the number to the right is, if it's 4 or less, like 0, 1, 2, 3, or 4, we are going to round down. If it's 5 or more, like 5, 6, 7, 8, or 9, we are going to round up. So we're gonna on A round to, let's round to 4 decimal places. So handy way of doing it is writing out those 4 decimal places and one more. You will never need, if there's like 10 numbers, but you're rounding to 4 decimal places, you won't need to write more than 5. The 4th decimal place is right here. 1, 2, 3, 4. So the 4th decimal place is here. The number to the right of it is a 6. 6 is in the roundup category. So the number we round up is the decimal place we're looking at, the 5. I've got 0.234, and the 5 is going to go up to a 6. We got 1 minute left in this class. Let's do a quick one for the other direction. Round to 2 decimal places or round to the hundredths. Let's write in the other terminology. Round to the hundredths place, which is the 2 decimal places. I'm going to write them all, but you don't need to. We only need to go over 2 decimal places, and we're looking at the 3. The 3 is our target number that we're looking at. We look to the number to the right. The number to the right is a 4, and that is in the round down category. Round down just means chop off everything after. So this is going to go to 0.23, and that's it. That's the final answer there. When we say round down, it doesn't mean lower the number. When I say round down. I'll pause the recording here. Oh, maybe not. Fun story. I took 5 of my friends to BlizzCon, which is like in 2018, 2019, something like that. 2017 maybe. Blizzard owns World of Warcraft, StarCraft, like a bunch of video games. BlizzCon is a giant convention for it. I took a bunch of friends to it. I was able to buy the tickets. Took them all to it, and they had one of those shuffleboard, like you slide the thing, the puck along the wooden thing. Does anyone know what I'm talking about? No one knows what shuffleboard is.
Yeah.
They have them in bars sometimes. So shuffleboard, you have seen people on both ends, and you've got little heavy pucks, and there's sand on the shit, and you slide it and try to get it to as far as you can without going over. So they had one of these there, and if you at the end there was a line, and they had how far you sent, and if you got it all the way to the end without going over, you got a remote keyboard that was backlit with all the multicolored backlit. It was like $100 keyboard at the time, and it was cableless, so like a remote keyboard. We were the first people in line, and so there's different categories and there's lines on the board, and I asked, what happens if we land on a line? Do you give the bigger prize or the smaller prize? And he says, we give the bigger prize. I'll give you the bigger prize. I don't know if he was supposed to, but I was the first one. He said, fuck it, we're gonna go with the bigger prize. Me, I got a mediocre prize. I didn't do too well. So I'm standing down at the end where the guy is doing the judging, and my buddy, the very next person, slides it, and his puck ends like this. Here's the prize things at the end, and his puck is just barely over the line for the good prize. Barely. I mean, just a sliver, hardly at all. And I saw the dude pause, and I started yelling right fucking behind him. Round up! Round up! He fucking jumped out of his fucking clothes damn near. I scared the shit out of him. I wanted to make sure he didn't fucking cheat my friend. Out of the fucking wireless, that's the word I was looking for. Cheat him out of the wireless keyboard. I scared the shit out of him. He did go get the keyboard. And my buddy carried that fucking keyboard around every single day of the convention. He didn't even take it to the car the first day. He was really fucking proud of winning that keyboard. That's it for that story. We got like 7 or 8 minutes till the next class.